Hello everyone, and welcome to another video on linear functions. So today we're going to be talking about how to write a linear function from words. So we've done graphs at this point, we've done tables, and now today we're going to talk about how to find a linear function using from words. So kind of think word problems. So let's just review what a linear function is. The first thing we want to talk about is a function rule. We've maybe mentioned this a couple times, but let's just define it now. A function rule is an equation. And since we're doing linear functions, we're going to stick with the equation y equals mx plus b, or slope-intercept form. All of our equations are going to be written like this, but since we're not doing a table or a graph, our slope is going to be just a little bit different today in the fact that we're looking for a rate of change. So today, our slope isn't necessarily rise over run or change in y over change in x. It's going to be the rate at which something is changing. So look for a rate in the problems. And the y-intercept, that's going to be the starting point. So before you even begin inputting, what do you have? And you want to focus on the slope and the y-intercept. You want to focus today on not only what value it is, but also if it's positive or negative. So let's go ahead and get started with an example. The first example that we have here is about babysitting. So you have $14 in your savings account. You babysit and earn $10 per hour. Write a function rule that represents the total amount of money you make babysitting. So if we want to look for what it is that is changing, and that is your rate. So if you look here, you have $14 in your savings account and you babysit and earn $10 per hour. That's your rate. Is your $10 in 1 hour. So if I look at if I'm not sure how to start this, I can create a table. So if you think about it, your hours are what you're inputting, it's what you're changing, and then the amount of money you have is what you end up with. So if you babysit 1 hour, that's $10 plus the $14 you have in your account. So that's $24. And if you babysit 2 hours, that's 2 times 10 plus the $14 you have in your account. So that's $34. And if you babysit 3 hours, that's 3 times $10 per hour plus the $14 you have in your account. And that's $44. And if you babysit 4 hours, that's 4 times $10 an hour plus $14. That's 40 plus 14 is $54. So from looking at this table now, we can go ahead and create our linear function or our function rule. And that's by looking at what's changing. So if I look here, I can see that we just have 1 here, and then we have 2, 3, 4. And then my 10 stays the same no matter what. And my plus 14 stays the same no matter what. So the thing that's changing is what's varying, and that's your variable. So that's going to be what your variable is going to be. That's going to be your x. So if we look, we can say that the total amount of money we make, this is our total, okay, it's always going to be 14. So we have the total is going to be $14 plus, and then it's $10 per hour. So $10 per hour. And if you wanted to write it like y equals mx plus b, you totally could. You would have t equals $10 an hour plus your starting point, which is 14. So that's your function rule or your linear equation. Now, what does the slope mean in this problem? So what is the slope or the rate of change? Well, the rate of change is right there. And what it means is that you make or earn $10 for every hour, 1 hour that you work. So your slope has to be a rate of something. It should be something per something. Oops, sorry. Okay. All right, let's look at another one here. Pizza. So the price for pizza is $6.95 plus 95 cents for each topping. Write a function rule that represents the total cost of the pizza. So if I think about this, if you were going in and you were buying, it's Friday night, and you want to buy pizza. So you walk in and you're like, I would like a pizza. And they would tell you that it's $6.95 just for the pizza. And then you're going to add 95 cents for each additional topping. So your starting point is going to be $6.95. No matter what, you have to pay $6.95. And then you pay 95 cents for each topping. So say, let's do our table here, and this is my cost. So T is your topping. So say I get one topping. I get $6.95 plus one topping at 95 cents. And two toppings, I still have to pay the $6.95 plus two toppings at 95 cents. And then say I get three toppings, it's still $6.95 plus three toppings at 95 cents. And if I would get zero, I'm going to squeeze this in here. If I would get zero toppings, I still have to pay the $6.95, but I would have zero toppings at 95 cents. So if I take and I look at this from the table, I can see once again that my $6.95 stays the same no matter what. So that's my constant. It's not changing at all. So that is my initial value or my Y. If I look next, what's changing is this part here, the 0, the 1, the 2, the 3, the number of toppings. And then the 95 cents stays the same no matter what. So whatever my variable is, whatever's changing, that becomes my variable or my letter in my equation. So now I have my total cost. So this would equal whatever my total is. So my total cost is going to be $6.95 for my pizza plus 95 cents per topping, depending on how many toppings I have. I probably shouldn't use a T. Sorry, I got a little excited there. Let's erase that. So we'll make this my cost. How's that? Sometimes you just have to change things. So my cost is going to be $6.95 plus 95 cents per topping. So what does the slope mean in this problem? Well, again, it's the rate of change, that you have, and that is 95 cents per one topping. And the initial value is $6.95 because no matter what, if you order a pizza, you have to pay the $6.95. So that's my y-intercept or my initial value. So I hope this gives you kind of a basis in solving these problems, kind of gives you an idea of how to solve them. You may not need to use the table, but if you get stuck, go ahead and set up a table and ask yourself, if the input was 0, what would I get? If the input was 1, what would I get? Sometimes looking at that and seeing what's changing and what's staying the same will help you.